So in this video, what I'd like to do is I'd like to make some realizations, some connections when it comes to infinite limits and limits as x approaches infinity. So I took them out. I didn't take the general limit from the 2 videos ago, but I did take the the one-sided limits, and then I took the limit as x approaches infinity, copied them from our last few videos, and I want to make some general conclusions. So I want to take a look at the limit as x approaches, actually, I don't think I'm going to go ahead and take out this one, because I actually don't need that one, but I do need this first one right here. So what we're going to look at is we're going to notice that, so we take a look at as x approaches 2 from the right side, so we're coming up this way. We concluded that that limit was infinity. So what I want to talk about is I want to talk about, well, what's going on here. So I think we would all agree that this is a vertical line right there, and what we would call this vertical line of x equals 2, we would call this a vertical asymptote. A vertical asymptote. So the cool thing to note is that if you find a limit, a one-sided limit that equals infinity, that is going to be a vertical asymptote. Whatever x is approaching, vertical asymptote at x equals a. Whatever x is approaching, and remember in this case, this 2 right here, that is a. Whatever x is approaching, so as you can see, x is approaching 2, the limit was infinity, there's going to be a vertical asymptote at whatever x is approaching. So at x equals 2, there is a vertical asymptote. The other thing I want to look at is I want to look at the limit as x approaches infinity. So when we were looking at when x approaches infinity, you can see in the blue right there, we were just kind of just trucking along, seeing, okay, as x is getting abnormally large, what value are we approaching? And the other thing that we could make conclusions about, which I can go ahead and establish in orange, I want to go ahead and say that this value is 3, is you can also say what is the limit as x approaches negative infinity, as x gets abnormally small. And in this case, we can go ahead and write that out. The limit as x approaches negative infinity of f of x, in that case, as we're getting from this graph, as we're getting abnormally small, it seems to be approaching this value, seems to be caving off at this value of 3. So what I want to notice is that, again, we can also find that there are asymptotes there, and there's an asymptote also right here. So we have asymptotes at y equals 3 and y equals 0. So whenever x approaches infinity, whatever value you get from these are actually going to end up being, horizontal asymptotes. So whatever value you get when x approaches infinity, that is a horizontal asymptote at y equals L, where L is your output, where L is your value for the limit. So you can actually find horizontal and vertical asymptotes simply by using limits. So you don't even need to use a graph to find asymptotes like you normally would have to do. You can just use calculus to find limits. Now, some of you are asking, okay, Trevor, we already did this in pre-calc. We were able to find horizontal and vertical asymptotes without calculus. Why do we need to know the calculus? You need to know the calculus because College Board is very good at testing you on content. They're not going to throw you trick questions that you aren't able to solve, but they are able to cleverly create questions that allow you to use use your basic calculus in new and interesting ways. So, like, for example, let's take a look at a practice problem. So we need to find the horizontal and vertical asymptotes of this function f of x equals 3x plus 5 over x plus 2. Now, naturally, if this is just a basic AP question, which we're going to treat it as such, we're going to need to justify our answer of horizontal and vertical asymptotes with calculus. So we're going to have to use calculus in order to find our horizontal and vertical asymptotes. So let's go ahead and do that. Well, we find vertical asymptotes when we take the left or right hand limit. When we take the left or right hand limit, and the left or right hand limit is equal to infinity. So I want to just take a look here. Where would the graph be equal? Where would we find? First off, we're going to use a little bit of pre-calc knowledge to help us solve this, but then we'll write limits and use calculus. Normally we can find vertical asymptotes when the denominator equals 0. So the denominator is going to equal 0 when x is negative 2. So is there any way we can So there will be, I'm gonna write that really small, at x equals -2. But are we able to use calculus to prove that? Well, let's go ahead and see if we can use calculus to prove that. So let's use the limit as x approaches -2. And I'm wondering, do I want to do it from the left or the right? I think I'm going to choose to do it from the right, because if I do it from the right, then I'm going to get numbers that are a little bit bigger than -2, and something a little bit bigger than 2 is like -1.9, and that's going to come out to be positive in the denominator so that we can get a positive infinity in the end. So I'm going to do the limit as x approaches 2 from the right-hand side of 3x plus 5 over x plus 2. And I'm going to find out that I'm going to get, 3 times -2 is -6, and 5, we're going to get -1 over, -2, something a little bit bigger than -2. That's going to be a positive small number. I haven't used this yet, but my calc teacher likes to call it a tiny positive. So, but it's the same thing as just, we have a small positive number. So this is going to be the same thing as -1 times a times a large positive number. So that's going to end up being, well, I guess in this case, -1 times infinity. I guess that would be negative infinity. But we could also approach it from the other side. If we were to take a look at it from the other side, we could take a look at it from the other side. So if we did the limit as x approaches -2 from the right, we would get 3x plus 5 over x plus 2. We would get -1 over a tiny, I did a tiny hashtag up here, I meant tiny positive, over a tiny negative, which would be -1 times a large negative. Again, here I just meant positive. I literally then wrote the same thing. Positive times a large negative, which would be negative times negative is a positive, and that would be the positive infinity. And that's kind of what we're looking for. So we can then conclude from these that there is a vertical asymptote at x equals -2, because vertical asymptotes occur when the limit as x approaches a certain number from one side equals positive infinity. So there is a vertical asymptote at x equals -2. How about a horizontal asymptote? Well, horizontal asymptotes occur when x approaches either positive or negative infinity. So let's do positive infinity at first. When x approaches infinity, 3x plus 5 over x plus 2. When x approaches infinity, well, what's going to happen in this case? Well, what's going to end up happening in this case is I'm going to divide by... I guess I actually don't need these. I don't know why I included those, pretend those aren't there, but I'm going to divide by the biggest power of x, which is just x to the first power. So we're going to get 3 plus 5 over x over 1 plus 2 over x, and we did conclude that these are going to end up going to 0, so these will go away. So, and then the limit of a constant is just that constant. So the limit as x approaches infinity is 3, and it's also true if x approaches negative infinity. There might be a different asymptote as we go to negative infinity. So let's just check. So we're going to get the limit is 3x plus 5 over x plus 2. Again, we're going to divide by the largest power, as we normally do when we find limits as x goes to infinity. So the largest power, we're going to get 3 plus 5 over x over 1 plus 2 over x. Again, these are going to go to 0, and we are going to get the same thing, that it's going to end up being 3. So then we can make the conclusion from here that there is a horizontal asymptote at y equals 3. So we have found our vertical and horizontal asymptotes, and we are done. So that is how you can use infinite limits and limits as x approaches infinity to be able to find horizontal and vertical asymptotes using calculus.